We are building the bit by bit project from the YByte Python curriculum available at www.ybyte.in. In the last video, we saw right shift operator. This video, we look at the left shift. In fact, the idea is quite similar. We take a binary, we take a, let's say a number, look at its binary representation. Instead of shifting right, in fact, we shift left by the value that has been provided. So that's really the idea, quite similar to right, but obviously the consequences of this are different. Let's look at it through some examples and then understand what exactly is going on. So like I said, let's say I do 43 left shift 1. Now the symbol for left shift is this, let's say, two leftward arrows. Basically, since we are shifting every bit leftwards, we extend to the right side by adding a 0. And thereafter, we shift every bit, let's say, by 1. And we end up with, for example, 86. So if I did 43, let's say, left shift by 1, that is 86. If I did, for example, 20 left shift by 3, so in this case, I go and add 3 zeros at the right side, and then I shift every bit over here. Now you can clearly see that this has the effect of multiplying, because again, just like we discussed earlier, the face value of every bit is increasing by 2 to the power of the shift. And no surprise really, the equivalent operator, arithmetic operator here is multiplying by 2 to the power of m. In fact, let's see this in action first before we take our discussion further. So let's say I did 20 left shift by 3. That is 160. No surprise really, because that's basically 20 times 2 to the power of, let's say, 3, which is in other words 8, right? So that's 160. If I did, let's say, 134, or say, let's say 34, let's say left shift by say 2, that's going to multiply 34 by 4, and that is hence 136. So really not very surprising, kind of similar. But there is one important point about left shift which I want to highlight here. When we do left shift, sometimes we may need to increase the bit width. For example, let's say I have a number 160. Now remember, if I were to left shift this by 1, I will add a 0 over here and I'll shift every bit out here. But notice the most significant bit here is in fact 1. In order to accommodate this, I will have to extend this bit width. So we can see this in another way. When I left shift by 2, left shift by 1, basically I'm multiplying by 2. 160 times 2 is 320. Remember, in an 8-bit setup, I could handle numbers from 0 to 255. For 320, I must add a new bit. And this is something a little bit interesting, something we have to be cognizant of when we are building, let's say, code. Many times we may want to say, okay, look, if it becomes more than 255, whatever I'm trying to do, I will in fact clip it all to, let's say, 1. In fact, we can write a function to do that. But by itself, left shift will do basically just this. Now, again, it helps to do a bit of compare and contrast with the decimal system. In fact, look at a decimal system. If I were to, let's say, do 20 left shift by 1, I would basically add a 0 at the end. I'll multiply by 10. 201 left shift by 1, I'll add another 0. I'll add a 0 at the end. I'll be multiplying also by 10. 157 left shift by 2, I'll be multiplying by 100 and I'll end up with 15700. Really the same thing is going on, except that remember, this being binary, the base is now 2. So if I were to do 20 left shift 1, that is 20 times 2, that is 40. If I were to do 201 times left shift, let's say, so let's say left shift by 1, that is basically, let's say, 402. In this case, there's an increase of a bit. Now, by the way, the increase of a digit is also visible here. When I go to 201 left shift 1, I end up with an extra digit. And that's exactly what's going on here, just that the whole base has changed. It requires a bit of thinking to realize that, look, now the base is 2 and hence we're looking at powers of 2. 157 left shift by 2 is 157 by 4, which is 628. Now again, in hardware, sometimes when they build hardware custom chips, this is a very powerful thing. Left shift can be used also to emulate multiplication with powers of 2. Just like right shift does division by powers of 2, left shift does multiplication by powers of 2. And this actually is quite a practical thing to know, and is often used in, let's say, power constrained hardware. Of course, that's kind of beyond the scope right now, but I hope you get the idea. I hope you are enjoying this journey, finding this whole discussion meaningful. These concepts can be a little bit difficult to understand, can be a little bit abstract, primarily because we are not so familiar with binary numbers. But as you are seeing, there's a clear similarity between the binary world and the decimal world. And with practice, binary numbers actually become quite natural to us as well. Um, all of this, by the way, will become very, very vivid when we look, for example, later on at the image, and also then when we build the LEDs activities. And that's the style at YByte. Concepts are always brought in context of an activity, because then the learning becomes very solid. Look at our website www.ybyte.in, and you'll find that we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.